If you recall, after you learned about numbers which are abstract, you were able to use numbers to represent physical quantities with realistic meanings. For example, 5 miles or 20 kilograms. Just like that, now you have learned about Cartesian vectors as a mathematical tool. You can also use Cartesian vectors to represent real physical quantities such as position or force. In an established three-dimensional Cartesian coordinate system, if a point P has coordinates of x, y, and z, then its position can be expressed by its position vector r, which starts from the origin and ends on point P. As a Cartesian vector, r can be expressed as xi plus yj plus zk. If you have 2 points, point A with coordinates xa, ya, and za, and point B with coordinates xb, yb, and zb, and if you want to find the relative position of point B relative to point A. This relative position can be expressed by a vector RAB that starts from point A and ends on point B, and RAB equals to position vector RB minus position vector RA. On the other hand, the relative position of point A relative to point B is expressed by the opposite vector RBA that starts from point B and ends on point A, and RBA equals to RA minus RB, and it also equals to negative RAB. We can also express force vectors as Cartesian vectors. For example, for the tension force F in the cable directed from point A to point B, we know that we can express it as its magnitude multiplied by a unit vector that describes its direction. How do we find this unit vector? Since the position vector from point A to point B has the same direction as the force, we can use the position vector RAB to find the unit vector UAB, which is given by this equation, with xa, ya, za, and xb, yb, and zb being the coordinates of point A and B respectively. Therefore, vector F equals to its magnitude multiplied by the unit vector UAB. Please note, just like the number 1, unit vectors are dimensionless, but position vectors and force vectors and also other physical quantities all have their appropriate units such as meters or newtons.